Hi, today we are going to discuss about the module 2, that is related to continuous distributions. We have already learned about discrete random variables in our previous classes. Now we are going to discuss about continuous random variables, okay? Continuous random variables. Continuous random variables. That is, in discrete, how are the values? How can you say the values in the discrete? The values will just like this, 1, 2, 3, 4, etc. But in continuous, the thing is that the values will be 0 less than x less than. Like this, it goes on. Like not every time this one, it comes differently. Is the way. So here we have already learned about some properties about discrete probability distributions, or it's how its PDF comes. With that, we have already discussed. Here we are going to study about continuous. This case, the difference is that in the discrete, we were having summation, right? In discrete, we were having, what was the equation? Do you remember? It was sigma p of x equal to 1, isn't it? In the same way, in continuous, we will be having the equation integral. Instead of summation, we will be having integration. That is integral minus infinity to infinity f of x dx is equal to 1. This is one of the basic equation. The other one is all the f of x will be greater than or equal to 0. These two are very important in continuous distributions. Okay. So the condition we use here is this. Okay. I think you can follow now. Isn't it? Okay. Now let us move to the next one. Okay. What is given other than that? It's given. Okay. You check here. What is given? Expectation of x is given, isn't it? What is expectation of x? Expectation of x is integral minus infinity to infinity x into f of x dx. Can you see? Integral x into f of x dx. In the same way, the only thing is that the summation is replaced with integration. Okay, now, what is here? Expectation of x square is integral minus infinity to infinity x square into f of x dx. What about sigma square? Sigma square is variance of x, isn't it? Sigma is standard deviation. So sigma square is variance. So what is the equation? Expectation of x square minus expectation of x to the whole square. Now we are going to discuss about cumulative. What about cumulative? That is f of x, capital F of x equal to integral minus infinity to x. In the discrete, we discussed it is up to less than or equal to 1, less than or equal to 2 in the same way. Here it is integration. So it's up to x. Okay. So capital F of x equal to integral minus infinity to x, f of x dx. When we get a reverse process, we already know integration is the reverse process of differentiation. We can just complement each other, right? So in the same way, it is written like this. Okay. Now let us do a problem. What is the question? A continuous random variable x has PDF, f of x equal to PDF was given. Already it is mentioned in the question that it is continuous random variable. The limit is also given. We have to find constant k. For that, what we will be having to do? We will to find integral. You already know the property that integral minus infinity to infinity f of x dx is equal to 1, right? You already know integral minus infinity to infinity f of x dx equal to 1. We are going to apply that in the same way what it comes. So in the place of f of x, what do we have here? In the place of f of x, we are having, what is in the place of f of x? Can you please say? Yes, it is k, right? So just substitute it. Integral minus infinity to infinity, f of x dx is equal to 1. This is our basic equation. We'll substitute like this. F of x is k dx equal to 1. So now, here it is minus infinity to infinity, but here what is the limit? Our limit is from 0 to 1. So you substitute that 0 to 1 k dx is equal to 1. Okay. Now just integrate. K is a constant. You can take it outside. So integral 0 to 1 dx is equal to 1. Integral 0 to 1 dx is actually x. Okay. So 0 to 1, 1. So put the limit. So what you will be getting? K is equal to 1. So we got the value of k. The question was, what was the question? The question was to find out the value of k. Is it clear for you? Okay. Next, you think about how to find p of x less than or equal to 4. Okay. How to find p of x less than or equal to 4. For that, what we are going to do is, the equation is like this. Okay. All of you, please look here. P of x less than or equal to 1 by 4. Not less than or less than 4. It's 1 by 4. Okay. So P of x less than or equal to 1 by 4. What you will do? This is equal to integral minus infinity to 1 by 4. Actually, it will be minus infinity to infinity, right? But we need till only 1 by 4. So minus infinity to 1 by 4 f of x dx. I will write here minus infinity to 1 by 4 f of x dx. Now you can substitute it here. Okay, is it clear? When you substitute it here, it is not minus infinity. The limit is only from 0 to less than x less than 1, isn't it? So it is up to from starting from 0 only. So you could change the limit. So 0 to 1 by 4 dx. That is 0 to 1 by 4 k dx. Actually, it becomes k. We already know, we have already found the value of k. So it is 1. So integral 0 to infinity 1 dx. So x is 0 to 1 by 4. So what is the value of the function? That is 1 by 4. Okay, is it clear? So if it comes like, if it is p of x less than or equal to 0.5, what will be the equation? Integral minus infinity to 1 by 2. 1 by 2 means 0.5 f of x dx. Like this, if any value comes, you can do it. I think it may be clear for you, right? So the main idea used here is integral minus infinity to infinity f of x dx is equal to 1. That is one idea, and the other one is probability of that equation. If you know both the equations, you could easily do that. Is it clear? Okay, now let us move to another, the same way, another example. So let us look this. What is given in the question? Given that PDF of random variable x is f of x kx. Later, the last question it was k, right? Here it is kx. The same question itself. So integral minus infinity to infinity f of x dx equal to 1. Integral 0 to 1. Just substitute the value for f of x kx dx. Integrate it. Okay. So you will be getting k equal to 2. What about this? P of x greater than 0.5. This is a similar question, so that I am not explaining it in detail. Okay. I think it's okay for you. If you have any doubt, you may contact me. Okay. P of x greater than 0.5. In the last question, what it was? What was the last question? It was less than or equal to, isn't it? Okay, let us check that what it was. Just let's go backward. It was less than or equal to there, but here it is greater than. So how you will do that? That is nothing to worry. Just do that integral 0. So if it is greater than 0.5, the value will be starting from 0.5. That is, the integration is starting from 0.5 to 1. So 2x dx, the value of k is 2. So 2x dx, so 2 into x square by 2. The integral of x is x square by 2. So we'll be getting square by 2. So 1 minus 1 by 2 square, that is 1 minus 1 by 4 is equal to 3 by 4. Is it clear for you? I think it's okay. Okay, shall we move to the next one? Okay.